Thank you for joining us today here at Interface. We are getting ready to start our presentation now. We have with us Keith Skidmore and Ken Bishop, who are responsible for our custom solutions and also have a long history working with Interface, helping our customers get exactly what they need, especially when it comes to systems and making sure they have all the components. Today, we wanted to talk about instrumentation. Instrumentation is obviously an important part of force measurement solutions. So with that, we're going to go ahead and get started. But please use the meeting chat feature if you have any questions. At the end of the presentation, we will be providing everybody an opportunity to ask questions, and we'll also address some frequently asked questions. So here we go. Let's get things started.
So here are the discussion topics for today's webinar. Next slide, please. So these are the instrumentation types that we're going to talk about today: signal conditioners, indicators, data acquisition, portable load cell indicators, weight indicators, junction boxes, USB interfaces, TEDS ready, and wireless and Bluetooth telemetry. Starting off with signal conditioners. Basically, what they do is they convert a low-level force or torque signal into a high level. And, you'll see this needed when you're connecting to a PLC or to a DAC. They come in many different shapes and sizes, in DIN rail mount types or standalone enclosures. They can also be put into an OEM module that can be integrated into a design. There's some nice features in a lot of them, which is filtering in case there's noise in the application. They provide stable excitation in case the device that you're using cannot. Isolated ground is a good feature, again, if it's a noisy type situation. And sometimes they come included in some of our indicator products, which we'll talk about later in our DACs. Power sources can be AC or DC. Nice thing is they can come in sealed packages in case you've got a aggressive environment that you're working in. And some of them can be vehicle powered as well, in case you're working in the auto industry. So high accuracy also is available, depending on which model you select. Next slide. Indicators. So indicators basically convert the sensor signal to a digital display. And they can be for either torque or force. And in torque especially, you'll want to measure speed and angle. So they're indicators that can do all sorts of different variations of force and torque, speed and angle. There are multi-channel versions where if customer has many different load cells, they could see the display of those on each different display. Again, stable excitation, programmable versions, which we'll discuss a little bit later in our weight indicator section. And what's nice about some of them is they have analog and digital output. So you can be displaying at a local application and sending digital or analog information to your control center or to other devices based on the weight or force or torque measurement that you're seeing. Nice features that can come along with it is peak or valley monitoring. So in case you're doing something where you want to see where something breaks, you can see the peak in that. And then we'll talk a little bit more about some portable versions in our next slides. There are alarms available. We have touchscreen displays. and can support many, many sensors up to 24 or even more. Next slide. Data acquisition. We have some nice data acquisition modules or instruments available. Some of the features of those are very fast processing speeds, up to 45,000 samples a second. They come with PC interface software, so you can use it to help set up the system, do logging and graphing. They also have analog and digital outputs, so you can send information to control centers. They have digital I/O options, so that let's say you're doing some kind of logging and you need a way to externally trigger a tear or start logging. You can do that through digital I/O. And then on some of our models, we have internal matrix math functions. And so that's required for 6-axis load cell measurement, where calculations are required to determine what the outputs are, the measurements are in any of the 6 axes. Support many different sensor types, such as force, torque, displacement, strain, temperature, pressure, angle, and RPM. And faster speeds means you get more data to analyze. So that's a great benefit of the product. Next slide. Portable load cell indicators. So a lot of times you're having a system that you need to move around mobily throughout, let's say, a facility, or you may be out on site. These are the type of indicators that you can take with you. They're obviously handheld. They still have a lot of the features like peak and valley monitoring. They have long battery lives, which can use power mode. They have shunt cal if you need that to check the health of the system. They work with TEDs. And some of the ones that we handle are very high precision, calibration grade. And on one of the models we have, you can even log to an SD card. So if you're out in the field, you can log to that SD card and then plug it into your PC when you get back and analyze the data when you get back in the office on your computer. Again, flexibility, mobility, and environmentally sealed. Next. Weight indicators. So these are geared towards weighing and scale measurements, but they work really well in other industrial type applications. They can be programmable. So if you have an application where you need to batch or mix different ingredients based on the weight, these type of indicators can do that. They can also send information back to control stations and trigger relays based on the weights or force and torques that they see. Displays are large and bright, so if they're used outside, they're easy to see. Because they're weight, sometimes those can only be compression direction, but ours are both bidirectional, so in case you're using it to do tension on cranes, they'll work really, really well with that type of an application. And many, many connections, scale or load cell inputs can be displayed and even summed if needed. So you could see individual weights and you could see total summed weights. Mentioned before, we can set alarms so that we can trigger other events, and sometimes safety. They're environmentally sealed and very rugged. Next slide. Junction boxes. One of the key features of a junction box is it allows you to bring in multiple load cells and then connect to a single input on a display. So you could use a single display indicator and maybe have 4 or 8 or even 16 load cells connected. What they allow you to do is trim the output of each different load cell so that they match. So if it was a platform, no matter where you put the weight on this platform, it would show the exact same weight. As we all know, load cells can have different outputs. So this box will allow you to make them all match and the readings all match. And again, these things can be expanded to 4, 8, 12, 16, depending on what your application looks like. One of the most common applications is a tank scale, where you have 4 load cells located on the tank, or 3 load cells, and then you're bringing that one reading into an indicator and then sending that information off to a control system. Next slide. USB interfaces. These are really great if you're going to do measurements with, let's say, a single load cell or single torque transducer. You can connect, or actually, buy these, and we can connect them up and scale them. So you can just plug them right into your USB port on your PC. They come with software, and you can log your readings instantaneously as you receive it and get right to work. We have versions that are multi-channel, and so they'll synchronize all the different channels so that your readings, your force readings, let's say, would be synced with your speed or your angle, or maybe the other 4 sensors if you have multiple sensors taking data at the same time. They do come with software, and they're pretty easy to set up and begin, as I mentioned before. And like I say, it's very convenient for the user, that's for sure. Next slide. TED's ready. So these are indicators with TED's capability. TED's means transducer electronic data sheet. And basically what that means is there's a chip on the sensor that you would put on the sensor that would hold the calibration that was performed when the load cell had its original calibration performed, and then the instrument can read the calibration information from the chip and automatically set itself up. So on our indicators, 9320, 9840, 9860, 9870, and the BX8, you can have as long as you have a transducer with the TEDS program chip in it, and you plug it into these devices, it'll automatically scale that device, so there won't be any errors of someone plugging in a load cell and the instrument not being scaled properly. Also, it allows for multiple sensors with a single instrument. So you can imagine you can put in a 10K load cell, unplug it, put in a 5K load cell, and automatically the instrument is scaled to the 5K capacity. So very nice feature. Next.
All right, this is
over to Keith.
Keith Skidmore. I'm taking over from here for the time being. Digital versus analog outputs. Digital is becoming more and more popular. Why digital? It can be lower installation cost if you have a lot of sensors and a lot of cable runs. Can work across existing networks. For example, if you have Ethernet IP, you might want to just interface into that as opposed to running analog signals. It's scalable, and that sometimes you can replace sensors and things without having to rescale, or you can do it all, say, digitally back at your controller. Multiple sensors can be daisy chained in a single cable run. Again, that's where you get into the installation. If you have a bunch of sensors, a lot of times you just want to piggyback into an existing network versus running cables all the way back to a controller or a data acquisition system. There can be some built-in error detection. You can detect things like open legs on the bridges and things. If you're digitizing at the sensor, you can be less susceptible to noise, and digital signals are usually very noise immune. Why analog? Well, analog is still faster. It can be a lot faster than digital. It's easy to work with. Everybody, a lot of people are very familiar with how to use analog signals. Less network bandwidth, as in no network bandwidth. You may have limited bandwidth, so if you start adding a lot of sensors in your network, it could slow things down. And a lot of DACs and PLCs accept analog signals. So, if you just want to stay with what you have, analog works quite well a lot of times. When you're selecting a system, deciding between digital and analog, one good question is there an existing network you need to connect to, right? And if so, if it's CAN bus, well, maybe you want to use CAN bus for your sensors. If it's, say, just pure analog, you probably don't necessarily want to convert everything over to digital unless there's some driving reason to do that. Again, if there's an existing DAC, if it has available analog input channels, stay analog. If it doesn't, you might have to add extra channels, or say it has an EtherCAT connection or something, you can actually use the same DAC without adding more channels by interfacing with it digitally. Budget, again, depends. If you have a lot of stuff that's analog, staying analog may make sense. If you have to add channels to your DAC, but you've got digital interface available, that can be a lot of a cost saving depending on how many sensors and how many channels you need. Again, how many sensors you're connecting, more sensors, sometimes digital makes more sense because, again, limited cable runs and connectivity. Next slide. Wireless and Bluetooth, handing it over to Ken Bishop.
All right. Next slide, please. Very good. Important considerations when using cableless instrumentation. So we have both wireless and Bluetooth. And so these are kind of common things you need to keep in mind as you're putting together your system. You need to always think of safety first. Need to make sure that your signal will not be interrupted if you're involved in any kind of safety applications. Need to be aware of the distance. That'll help you choose the right type. Clear line of sight. Make sure that metal objects and walls and things are taken into account. Battery life. Most of our wireless product runs off of batteries, although we do have options that you can wire in. You need to be cognizant of the battery life if you're using the batteries. If you need logging, that'll help you choose which one's the right system, and your system design and the data rate that you need. Next slide. So today's wireless, when we say in this presentation wireless, we mean our WTS system, and that is a 2.4 gigahertz transmission, not Bluetooth. And so we've got different types of inputs. We can integrate wireless transmitters into our products, which we do. And we can also do external transmitters. So we can connect to any load cell that we make, either integrating it or connecting external with a acquisition module. Next slide. Then we have different receivers that have different capabilities. We have regular base stations that plug into the USB and use software and do logging, graphing, and Keith will tell you a little bit more about that as we move along. We have other ones that do gateways that can help you connect to your network, and we can connect to LED displays. But the nice thing is that the signal is transmitted, and these type of base station receivers can receive them simultaneously. So you could be using a handheld at the same time your display is seeing the output and also sending information to an analog output, which could trigger some kind of machinery or activity to happen. Next slide. Advantages of wireless. Of course, no wires, increased efficiency and cost savings, the flexibility and expandability, as you've seen from all the options that we have, different ways to set up full systems using wireless. Again, we can use connect it to most any sensor that we make, and you can put it on moving parts. We've helped customers that have slow moving, even torque applications, where they can put a wireless acquisition module on that and transmit wirelessly to a PC and a handheld. And then for areas that are difficult to access, you can get in there, connect it up, and then no wires will be necessary to get transmission or get data from your sensor to the system. Next slide. When is wireless not a great option? Well, if you have a lot of signal obstructions, when you have security concerns, right? People can pick those signals up through the air. So you need to be careful with that. A high data rate. High data rate usually takes a lot of battery power, and also a lot of bandwidth. And sometimes the wireless system doesn't have as wide of a band rate, let's say, as a wired system. So You need to keep that in mind. If there's any other interference with other wireless signals in your facility, obviously that would interrupt the transmission. And then long running measurements where you're going to keep those samples going, and they're critical. If the battery obviously dies, you're going to lose the recording of the data. It'll interrupt the data recording. Next slide. So Bluetooth advantage, obviously it's lower cost because you're going to be using a device that you probably already have, your cell phone, an Android or Apple device, or your iPad. So it's easy integration. Just download the application, and then you have an acquisition module, which is the one that's on the left. You connect that to your load cell, your force sensor, your torque transducer, and you're immediately seeing things on your phone. You're not getting any logging, so just keep that in mind. Next slide. Some of the disadvantages: it's easier to lose a connection, and the bandwidth is less than our regular WTS wireless. Shorter communication range, somewhere in the 50 to 90 meters, I think, as opposed to our WTS system, which goes up to 800 meters. And with the repeater, it can go even more. And of course, security is always a priority, something to keep in mind when you're transmitting data wirelessly. Can we turn it over to Keith
again? Talking about software and data acquisition. We have a number of software packages that are compatible with various of our different pieces of hardware. So we're going to talk about those now. We have three major categories of the software. One is our BlueDAC software, and there's a number of different devices that work with that. WTS and BTS toolkits and logging, those work with the wireless systems. And then we have another category which works with our torque sensors, and another category of instrumentation, which is like USB modules. BlueDAC, starting with that one. This one, it can display up to any number of channels. It's compatible with our 9330 high-speed portable display, and that instrument can either take bridge signals or it can take a high-level voltage, but not simultaneously, so it's only one at a time. The BSC4 is a 4-channel device, hooks up via USB. That has a variety of different selectable input ranges, millivolts per volt, volts. You can hit temperature sensors up to it. Does bridge completion with strain gauge, quarter and half bridges, so you can do some strain gauge work with that. The BX8 is an 8-channel system that works again with a whole bunch of different kind of inputs. It actually has 2 extra pulse counters that can be used with encoders and frequency inputs, so a total of 10 channels. You can hook all of these together simultaneously, so you have a BSC4 and a BX8 all hooked up to the software at the same time. BX8s can all be synchronized, and they multiply, so you have like say 16 channels of BX8, and they can be synchronized. Internally, the BX8 samples synchronously 48 kilohertz on all 8 channels. You could have 2 of them, synchronize those together, you have 16 channels. Moving on, the software with the wireless is pretty cool. It's got a toolkit that lets you do all the configuration and setup. You can also do some logging with the toolkits, and you can do things like signal analysis to make sure you're getting good signal strength and all that. There's also a visualization software that actually just shows you displays. It's called Log100. You can actually have up to 100 displays simultaneously. There's also a feature where you can overlay the displays on top of a photograph, which is what we show here with, say, an airplane. This is pretty basic, but it's very handy. An airplane, you're jacking the plane, you want to make sure that it's lifted evenly. So each waypoint or jack point actually has a display overlaid on it. These are actually set up to go, green, yellow, and red. So if you're starting to get too much weight on a single point, it'll show red and alarm. And then to the right here, these are actually applications that work with Bluetooth, shows Android and iOS implementations. FVS3, this is software that works with our INF USB interface modules. There's also an SI USB 2 and an SI USB 4, which are 2 and 4 channel devices. This software has, triggers and graphing and logging, and it can do some pass-fail. That's where the green smiley face is. So you've met a certain criteria. Say it could be torque to turn. So as a torque fall within a certain angle, you can get a pass versus a fail. It can automatically log the data if you get a pass or fail and mark the data accordingly. This is a version of that same software, but it's specific to the USB torque sensors. And again, it can do torque, power, angle, speed, graphing, and logging. Next slide, trends and systems. So what's trending? Definitely trending more towards more data being analyzed, and to do that you have to have more channels, and basically taking data, maybe even things that you wouldn't have necessarily recorded in the past. People are recording data, so then in the end, something goes wrong, they can go back and do some analysis and see where something went wrong. So the more data you have, the more analysis you're capable of doing. Some of that trends towards digital. We got more and more customers leaning towards digital, again, either interacting with existing networks or making new systems and just starting go say EtherCAT instead of a pure analog. Wireless also real popular, and we when we first started doing wireless, like, well, who would use wireless? Trying to think of use cases. Turns out there's all kinds of cases for wireless if people don't want cables. Basically, sometimes you've got people running over cables. You got cable runs through troughs and things. It can be much easier sometimes to set up a wireless system. Digital protocols, we can support just about any protocol. CAN bus, EtherCAT, Ethernet IP, Modbus come to mind. We do RS-45, ASCII if somebody wants something easy. We can do higher speed. Some of these like EtherCAT supports quite high data rates. Get more channels of data. Again, if you're trying to do post-analysis, sometimes, you don't know it's important until there's an issue and you want to go back and look. So people are trying to look at all different aspects of an operation, including acquiring force, torque, pressure, temperature data, all this data that really is going to be used later to analyze if there's a failure. Moving on, when you're building a system, might want to ask, where are you going to connect your sensor and how? It's important to think about that when you're, at the beginning, not in the end where you have your sensors and now, whoops, you didn't have the right interfaces or whatever. So it's important to think of it at the beginning. You need to log or store data. Sometimes you just want a visual display. Sometimes you actually want to be able to log, store data. Sometimes you even want, graphing capability, those kind of things. You need to think about that. Do you prefer analog or digital? Some of that depends what systems are already existing. If you have a bunch of analog inputs in a data acquisition system, then analog probably makes sense. If you don't, might make more sense to go digital if you're setting up a new system or you have a system that has, say, all of its channels full of other analog inputs, and you can connect, say, to the digital input instead. Are you going to use handheld or wireless, or do you want something that's hardwired? That's a consideration. Again, how do you want it displayed? We've got very large displays. Say you have an overhead crane, you want a gigantic display that people can see from all over the factory, or do you just want a local display, or do you want, no display at all? Again, how many channels? It's important to think about that at the beginning. Some of these instruments are better if you buy, more channels in one box, for example, instead of, kind of piecemealing, adding things together. If you think about, okay, I've got, some pressure sensor, I've got some displacement, a bunch of things you want to measure. Maybe it makes sense to start thinking about that as a total package at the beginning instead of buying a bunch of independent things and then trying to hook them together in the end. When designing a system, sensor, power and excitation is very important. If you have a millivolt per volt bridge level sensor, you have to deal with that. So you may need a signal conditioner, or you need a data acquisition system that can handle bridge signals. If you're using 4 to 20, it might be loop powered. Might have analog voltages, and if those say are amplified sensors, they need certain power requirements. So when you mix and match systems that or sensors that have different power requirements, important to understand what all those are. And certain things, for example, maybe have voltage requirements, but they may not be the same. So one might require 24 volts, one might require 12 or something. So it's just important to think about that so you don't end up with a system that's mismatched. Performance standards, do you have accuracy or speed considerations? Every time you make a conversion, it adds error. So if you say you analog and you digitize and you convert back to analog somewhere and then you back to digital, every time you make that conversion, you can potentially introduce error. So it's important to think about environment, temperature, wet, heat, is it physically demanding? Is there movement? You can get cables worn through. Again, connectivity, you've got a lot of these things have connectors on them, so you need to make cable runs. What are you interfacing to? It starts to make sense. If you have a bunch of screw terminals, that can be a pain in the neck. So maybe you want an enclosure that has connectors on it instead. Then you have cables that just plug in instead of having to do a bunch of wiring. I think this one is off to Ken.
We're going to tell you some tips, some things to consider when you're pick the right instrumentation. Know your power supply and what kind of filtering you'll need and what input range. Those are really, really important in the beginning, as Keith has mentioned some of those. Know that your signal is going to be, in a lot of cases, a very low millivolt per volt signal. And so its output is directly affected by the voltage. So we want to make sure you have a nice stable excitation voltage supplying as you're putting that thing together. Make sure your data acquisition systems work well with low-level signals, or you have the option of adding a signal conditioner, which we can put together and scale it for you. DAC system won't always provide a stable excitation voltage, so you can still use a signal conditioner with that as well to help provide a stable power source. Next slide. Make sure you always consider the bit resolution. We have instruments that have 16-bit and we have some that are 24-bit, but in the end, what that translates down to is that you'll have more ability to divide up the measurement that's coming from your load cell or torque transducer. And so if you understand that if you don't have much resolution need, then maybe you could go with one with a lower bit count. But the more bits, better resolution for you. So keep that in mind. Know your internal sample rate requirements. So again, we sell indicators with 5 samples a second, and then as Keith mentioned, we go to 48K samples a second. So understand what speed you need, make sure that you select that. We have a great group of people here, our application engineers, that can help you select the right one. Filtering can help reduce the noise in the signal, so many of our instruments offer that. So if that's something that may be of a concern, make sure you pick one with filtering capability. Digital signals are less susceptible to noise and allow for multi-directional transmission. So keep that in mind. If you have those kind of requirements, digital would be the better choice than analog. Next slide. Talk a little bit about cables and accessories now. In regards to cables, something to consider in the beginning is your cable runs. There's certain instrumentation types that can provide what we call excitation sense. And so if it's a real long run, you may want to have excitation sense connected to your cable so that you won't have a voltage drop over the distance. And then, of course, if you've got long runs where you're going to use multiple sensors, it may be better to consider digital. So that way you can daisy chain them together and get your information that way. You also need to consider, where is your instrument going to mount? Is there power nearby? And if it's outside, you need to make sure you've got the right enclosure to keep the moisture, the environmental concerns away from that instrumentation. Next slide. Common accessories, TEDs, we've talked about that a little bit. That's where you can purchase your load cell with the transducer, electronic data sheet, chip, and it has your calibration data for the load cell stored inside. And then, of course, you'd buy a instrument that had TED's capability, so it would automatically scale that load cell to the instrument when it's plugged in. Also, mating connectors. They're typically supplied with the instruments, but not with the sensor. So you need to think that through. And again, our application engineers here can help you select the right options to make sure that that particular connector for that instrument gets installed onto the load cell cable. Or as the next bullet says, or they help you select the correct interconnect cable. So an interconnect cable to us is a two-ended cable, one for the load cell, one for the instrument, or one for the torque cell, one for the instrument. That allows you to connect those two things together. Output signal cables, so we're going from the instrument to your system, maybe an analog output, that kind of thing. They're not typically included. We certainly can supply them if you need. All you got to do is mention it to your applications engineer, and they can help you put together a quote for that. And otherwise, you can also build them on your own. Next slide. And cable options. We use, if we make our cables here, of course, we use the highest grade cables along with our highly skilled operators to put this together. And of course, we've designed those cables to work with Interface products. They're made with the highest quality components and people to do that work. We created them to maintain the specifications of the product so you can get the same performance we're getting here at your site in your application. They're great for connecting the transducer to the instrumentation, and we can make them in standard lengths or custom lengths, depending on what your need is. And we typically use a shielded cable to reduce the noise along the trail. Next slide.
All right, we're going to talk about some applications with certain instruments. This is a pretty neat one. We have sold a lot of brake pedal load cells. Usually they're hardwired into, say, maybe an instrument that's sitting on the dash or just some data acquisition system that's in the car. Sometimes though, people have trouble with the cables. They maybe kick them or they pull them loose. And so this is a system where a wireless Bluetooth transmitter was hooked up, and basically the cable's tucked away, and it's just displaying on a tablet or a phone. And so sometimes there's somebody driving along and the operator is, pressing the pedal, and somebody's, making sure they're hitting it with the right force level. So just an option to go wireless. And a lot of times wireless just gets rid of the cable run and cable snags and issues that can happen with cables. This is a common application. We're starting to do more and more with, not necessarily super precise force measurement, but just force or weight monitoring. This is an aircraft engine that's being hoisted and then moved through a facility, and they want to make sure the weight distribution is correct, or so it's not like getting hung up on something or whatever. And so these actually used wireless shackles, and they transmit to a wireless system, so you can be monitoring it with handheld display. Again, if this is going to be moving through a factory, it wouldn't necessarily be great to have a cable hardwired to it, so this allows it to transmit wirelessly. Here's another one. This would be a weighing application. A lot of times these would use a specific weighing display or controller. This is a silo, so typically these would be summed together. Some of these weighing instruments, though, can also just look at each channel independently and then sum them together in the display. That can be useful. For example, say there's a lot of wind loading. You want to make sure that the thing isn't getting a little light on one side. You could tell that what's happening with a system like this. You can also have programs, so if you're filling a silo, it'll actually automatically start and stop the conveyors and the pumps and things. On to Ken.
Yeah, this is a friction testing application. What we have is our 3-axis load cell connected with our BSC4, and basically what's happening is there's a weight on the product, and as the specimen is being moved across the surface, they're getting loads in the Z direction and the X and Y direction from the friction, so the force of the weight down, and then the dragging is causing the loads in the X and Y direction. Information is captured on our BSC4 and then transmitted to the laptop and then logged and graphed with the BlueDAC software on the PC. Next slide. This one is a crane lifting application. We use our WTS LTL, so this is a lightweight wireless tension load link. It's transmitting its signal from the weight that it's lifting to a wireless handheld display, also to a relay module, and to the PC. So we're able to read the measurements on a handheld display, able to trigger events through a relay module wirelessly to our equipment or to alarms, and also log the data to a PC all simultaneously. Next slide. This is a tablet forming machine. So what's happening here is we're basically using a model WMC load cell connected with our 9320 indicator. There's no logging here. This is basically a display operation. Somebody may be monitoring a piece of tool, making sure it's applying the proper force in the factory. So they run a test, they get a measurement. They could also use peak valley to capture the peak force that was applied, make sure it's not too much force to break the tablet, and record it manually or pass or fail based on what they see. Next slide, please. This last one's kind of a system that we put together using our 9812 WTS wireless panel mount display. The case itself has a battery in it, a rechargeable battery. You don't see it pictured, but it's underneath. Then we have 4 each of our model 1200 series WTS. So they have integrated wireless acquisition modules inside. And so this can be used for a platform application. Someone could load each of any one of the load cells on the platform and get an individual reading on the display of the 9812 WTS. And of course, since it's our WTS system, you could also connect through our WTS base station to the PC and be logging and graphing the data as well simultaneously. I could even do a mapping as we saw with our airplane application, if applicable. Next slide.
All right, frequently asked questions. Does instrumentation typically come with software? Very good question, and it depends. Some of digital systems do not, and so they're required to interface into, say, existing software. The customer has to write their own software. Some of them certainly do come with full-on data acquisition and logging packages, so it's a good question. Some of the displays, for example, may have digital outputs, but no real software available. Against ASCII, it's easy enough to write your own or to interface with something, like a terminal program or something. So it depends. Some of the older equipment definitely doesn't have a lot of software that goes with it. What are common software programs? Well, LabVIEW is very popular. Some people use MATLAB for more analysis. Certainly there's a lot of data acquisition systems out there, Gartner, DeweySoft, DeweyTron, they all come with their own software. So typically it depends on the hardware. Can you use multiple instrumentation components with the same software? I think we meant to say software here. It depends. Again, there's compatibility for using LabVIEW. You might want VIs or LabVIEW compatibility. If you're using our software, then each software sort of family has a number of pieces of hardware that easily work with it, and then some of them do not. So if you mix and match incorrectly, you might have things that don't work together. So it's important to bring that up and to discuss it with your application engineer. What are the limitations using disconnected instrumentation? That would be, I guess if you've got separate instruments instead of a single instrument having multiple sensors. Some of it could be the synchronization of the data. If something's happening, say you're doing a pull versus displacement test, you want to know when it breaks, not only what force level, but at what elongation. If those aren't synchronized, say you're running 2 different separate systems over a USB into a laptop. It looks synchronized, but in fact, USB and Windows may be, not really synchronizing those together very well. So again, if you have a single system that has 2 inputs and 1 connection to the PC, a lot of times those 2 measurements are synced together in the device and then transmitted to the PC afterwards. And that's another case too. When is multi-channel instrumentation ideal? If you have a lot of different data sets that you're trying to bring together, it makes it easier if it's all into one device, and the software basically just pools the data in a single data packet. What type of battery life can you expect with handheld devices? Well, pretty darn good. You know, it's not like the old days where you might have to put batteries in it every day. A lot of these things have battery life extension features, such as that they shut off automatically after, you know, X amount of hours. That's programmable. But typically it's measured in months, not days. Some of it depends on battery, or I'm sorry, on data frequency. If you're going to, you know, blast the data at full speed continuously, you'll get less data life or battery life. But again, you know, it's measured in weeks then, not minutes. Do you offer guides or tutorials on setting up instrumentation? Absolutely. We have quick start guides, we have videos, and we should have that for all of our stuff. And if, you know, someone finds that they need some help, we'll put something together. Or actually, we do a lot of webinars, or I should say video conferences, where if you have a system, we can actually walk you through. We do that a lot with the wireless stuff, where you get somebody on the phone, you know, we have a system set up here, we share our screens, and you go through all the settings and make sure it's all, you know, set up, and make sure the customer understands how to do it. Common connectivity challenge. Well, a lot of times if you have a bridge level sensor, which a load cell is, you know, people try to hook it up to, say, a data acquisition system that isn't necessarily intended for that. And so some systems have voltage inputs. They may have the ability to, say, scale that input range down into the millivolt range, maybe 50 or 100 millivolts. Not necessarily ideal, though, for connecting a bridge signal. And so you have to be careful. Just because you have a low level millivolt input, it doesn't mean that a load cell hooks up to it easily. And so what you probably want to do is use a signal conditioner and actually use like a 5-volt input range, and use a signal conditioner to bring your voltage up to the higher level input. What are the advantages of self-indicating instrumentation? They're very useful for troubleshooting and local display. So for example, say you have a data acquisition system or a PLC monitoring a process, you don't really need a display. But if there's local display, you know, when you're doing some setup, if you're doing calibration, you can actually eyeball the display right there. Also, if you're getting readings, say, back at your PLC that don't make sense, well, you can check out the display on the instrument, right? And if it's reading correctly, well, you know it's some problem with your PLC or the cabling between the instrument and your PLC. On the other hand, if the display isn't reading correctly, well, you don't need to mess with your PLC, right? Because you know that the problem lies actually in the actual instrument or the load cell or cabling between the two. Next slide. We're done.
Y interface. And you can see the bullets there. 53 years of experience. We have a range of sensor options. We have high accuracy product. Many components that we can help you turn into a system. An engineer in-house, and we've done custom instrumentation as well. And so if you don't see anything you need on the menu on the website, let us know. We can put something special together for you. And of course, our technical support and application expertise is second to none. Jamie?
Well, we've got a couple of questions in chat. So if you don't mind, Michael would like to know, he's looking for a digital interface that can communicate with a CRIO using a digital input module counter. So it would be something like a SSI interface or PWM. However, it needs to be relatively fast, about 10,000 samples per second. Do you have anything that addresses that type of use case?
That's a good question. And the short answer is not immediately apparent, no. But we'd want to dig into that one a little deeper. But we're not really doing much with SSI, and 10,000 samples per second is pretty high. You would wonder what the actual application is. You know, load cells, typically that's, you don't typically need that fast with load cells. You're doing like impact testing and things. So anyway, we might want to discuss that further offline, but I can't answer that specifically right now.
All right, Michael, we'll follow up with you. Andrew wants to know, are there any advantages, and you answered this a little bit, but just are there any advantages to getting a single channel indicator versus a dual or multi-channel indicator?
Yeah, I think
well, single channels can oftentimes be less expensive, so that's a serious advantage. A Although if you find you want to add a second channel later, a lot of times you have to buy a second instrument where the dual channel might have been more cost effective if you went that way in the first place.
Yeah, and it depends on your application, right? I mean, we've had customers that want to do center of gravity, so it's not possible to do center of gravity with, you know, let's say one display. You want to see the output of the 4 different load cells, let's say, and then where the center of gravity is located. So it's really application specific.
All right, thank you. I know we have some people using the chat feature. If you've had any difficulty in using the feature in this event, please be sure to reach out to us. We're happy to address any questions. We do a lot of instrumentation solutions, not only just with what we have to offer, but with existing systems. A lot of people looking to upgrade their instrumentation to get different types of logging, graphing, readouts, all kinds of stuff. So with that, we want to thank everyone for joining us today. This will be archived on our YouTube channel along with all our other events. We'll also be sending you a follow-up so that you'll have the recording and can reference it at any time. Keith, Ken, as always, thank you for your expertise and sharing with us today. We appreciate everyone joining. Have a great day.
Thanks, everybody.
Thank you.